Uh, so yeah, this talk is going to be about Frappe Flow. It's going to be a sneak peek, but not exactly, and you'll see why. So some background about this: around a month and a half ago, I started working on a new product, like Frappe Flow. I called it that, and it was to be a workflow editor. So kind of like N8N, and you all are familiar with that. There are triggers, and some condition will be there, and then you execute some task. I don't know if you all were there for yesterday's talk by one of the participants. So they had demoed N8N. But after a month or so after development, I got pulled into this call about existential concerns. And it was because someone on LinkedIn had responded to a post that Rushabh had said saying that LLMs will obsolete an ERP. And so he was like, oh, this is actually going to happen. Because of that talk that I had with Rushabh, even Faris and Aditya were there in that, and because of my experiences playing around with LLMs and LLM-based tools, I thought that should I pivot the app to something else before that, but I thought, okay, let me at least try building a POC. So this is about that POC. It is not about like a full-fledged product or anything. It's just, it was 1 week of me throwing code at a wall trying to see if I can get anything out of it. And so I'll show a quick demo, and I'm fully expecting things to break. Let's see where it goes. So here I have, okay, this is not visible. Is it visible? Okay. So here I have the kind of interface that most people are familiar with. If there's an input box similar to ChatGPT or whatever, and I can ask, okay, it was not supposed to speak in Markdown, but it basically has access to this Frappe instance. I have kind of mocked the instance, but I have given it a bunch of tools. So you can see that it says that I can handle support tickets in help desk, work with discussions in game plan, and a bunch of other similar things. So I can ask it like, and it'll check the discussions and then get back to me. So this obviously is not like the kind of task you would do using something of an app of this sort, but you could imagine it helping you prioritize tickets or a bunch of other similar things. So here it has fetched the discussions and responded. And then I can ask it for specific things like dropping comments or ask it like what the summary of a particular discussion is. But I'll move forward because I have kind of mocked the actual thing that's happening behind the scene. And I'll explain what is going on later on in the talk. So I hope that the question that you guys have is, how is something like this built? Otherwise, my talk is kind of pointless. So I'll move ahead with that. Before that, I'll just give a quick 5-minute tangent on what an LLM does. So if you all have watched the Andre Karpathy talk about a quick, not a quick, like a deep dive into LLMs, this is like a 5-minute, very lossy compression of that. So the first thing is people hear a lot, have heard this phrase a lot, that an LLM predicts the next token, but what does that mean? Like what does predict here mean and what does next token mean? So first, coming down to tokens, so LLMs don't see in terms of like words or characters. They understand tokens, and tokens are basically sub-word level strings, and you get to this quantization of characters by using a process known as byte pair encoding, where similar characters are assigned a new value. And so you see that understanding is like 2 tokens, and tokenization is also 2 tokens. It's not like 1 token it's not 1 number assigned to each word or each character, but it's something somewhere in the middle. They usually say that a good rule of thumb is 3 tokens per word, but here it's not exactly like that. And what does prediction mean? So I want to show a visualization for this. And here what I have is an interface into Meta's Llama 2. And if I start typing something and then get it to execute, I just say hi and then press enter. And then you can say that it is completing what I have said. It starts saying hibernation and something on the other. So basically, it's just predicting the next sequence of things. So another example would be if I type, it'll try and complete the function that I have written. And similarly, if I do so here I'm trying to get it to, prime it in a way to follow this turn-based conversation between a user and an LLM. And you can see that it's kind of going ahead and then completing the sequence of conversation. But this is how an untrained, unfine-tuned LLM looks like. It just like predicts the next token. And then the question is, how does this become usable? So what happens is that you train these models, like after doing this sort of fine-tuning, you train it to converse. And here is an example from the paper behind ChatGPT. And the question that they gave it was, why is it important to eat socks after meditating? So you can see that without fine training, it just like goes on and then it's not conversant. It just like tries to complete and then ask more questions and then like answer on its own. Similar to like how I showed you, where it was auto-completing the turn-based conversation or completing my Python function. But after doing instruction training, it starts giving an answer, saying that there's no clear answer to this question, but there are many theories and ideas. So you can see that it's made up something. Obviously, eating socks after meditating is, I'm assuming it's not a thing. I don't know much about that, but I'm assuming it's not a thing. So you can see that here, a preview into hallucination, wherein it just makes up things and then but it still answers in a conversant way. And then after doing this training to converse and following some instructions, they kind of trained it to use tools. And which is, I'll speak about that later, but here, by what I mean trained to use tools is that you can see it, they train it to emit these special characters, and you can see this QA, and in brackets, it looks like a function call. So what happens is that the thing that is looking at the LLM's output sees that, and then replaces that, adds the answer to that function call. So you can see the question here is, who is the publisher of the New England Journal of Medicine? And the piece of code that is looking at the LLM output will see that, run whatever actual code is there for the QA function, and then add the output Massachusetts Medical Society. And then the LLM will use that and then like continue generating more tokens, just saying the MMS over here. And finally, this is more of a recent development with like models like O1 by OpenAI or DeepSeek's R1, wherein they trained it to sort of think. And by that, what I mean is they asked it to emit the specific think token. And in the think token, it is allowed to sort of reflect about the question that's given to it. So here it's a mathematical a problem that is posed to the LLM. And this is from the DeepSeek paper. So it's from late 2024 or so. And in that, you can see that it's thinking about how it should go about solving the problem. And at some point, the text in red is an emergent behavior. So emergent behavior is behavior that people don't, the researchers don't expect the LLMs to do, but then like they kind of do it because of the nature of their training. So here it's saying, wait, and then it learns to like second guess its prior presumptions, and then like it goes over what it thought earlier. And then finally this think tag, it comes to an end, and then it looks at what it's thought and then gives you an actual answer. So some takeaways here are that everything that you do with an LLM, it has to be framed as tokens. So its input is also tokens, output is tokens. And nowadays you have multimodal LLMs, as in you can like directly speak to it, or you can give it images. And that too is broken down into tokens. And there aren't any hard-coded rules. So everything is probability based. And you can see how in the earlier example that I gave, where it was auto-completing my turn-based conversation, it had to be trained to emit a stop token so that after the LLM says what it has to say, it doesn't go on to generate what the user is saying, because that's what we are saying, we are telling it. And then finally, it doesn't have code execution. So it will emit tokens to look like a code execution, but we have to execute the code, give it the response, and then it looks at the response and then answers what you have to say. And additional behavior then has to be trained to it. There are like some emergent behaviors that you can expect, but special things have to be trained. Some of these are like hacks. Like in this, you can see that this is kind of a hack wherein you get it to emit a think token and then ask it to think. So, and the the demo that I showed you, that is based very heavily on the tool use feature that LLMs kind of have been trained to do, and that ends up being the crux of such a system. And here I try to think of tool use as like an interface between the unstructured input that an LLM gets or it generates versus structured. So yesterday, Nikhil had said, deterministic versus non-deterministic, and you can think about it that way too, wherein the input that output that an LLM generates, the tokens, they are probabilistic in nature, but the code that you run based on that is like deterministic. So they are kind of related concepts. And so this is the layout of the demo that I showed you. So I was speaking with this main assistant LLM, and what that does is it has got access to this invoke tool, and then it invokes other LLMs to get special stuff done. So when I asked it a question about game plan, it invoked the game plan agent, and then fetched the discussion or like the list of discussions, looked, then the game plan agent gave it to the assistant LLM, and it was able to respond on the basis of that. So here I have another interaction that I had done earlier, and I have an inspect mode, inspect invocations, and you can see behind the scenes what is happening. So here when I ask it a question about what's the latest engineering post on game plan, it's invoking an agent, and then it's giving me a bunch of, so basically this invoke agent is a tool call, and the things that you're seeing here, explanation, agent name, task, context, they are arguments that are passed to that function invoke agent. And so this is generated by the LLM. In this particular case, I rejected it, and I denied the request. And it basically said that, okay, I need to do it. And then I told her that, okay, fine, can you check again? And then it asked again, I accepted the request. And then finally, it invoked, before I come to this, I'll show you. Here, when I called invoke agent on its behalf, it was basically the assistant generating prompt for the agent LLM. And this was the prompt. So this is, you can see that here it says game plan agent invoked by assistant. And the assistant is telling it to fetch the most recent discussion sorted by date. And then here in blue, what you're saying is what the game plan agent does, which is that it calls the list discussion tool. And then you can see the final response here. So this response is then appended to the invoke agent tool call on top. And the assistant LLM looks at this appended, the result for the invoke agent, and then it gives, it asks like more questions, and then like it basically collects more data from the agent, from the game plan LLM, and then like it finally gives me a response on the basis of the data that it has fetched. So that is kind of the behind the scenes. I don't know, do you guys want to see like how the agents and assistants are defined? Like that is in code. I had not planned on that, but okay. So yeah, here I have like, yeah, okay. That's cool. So here I have defined some dummy agents and kept. It was just for the purpose of testing for the POC, and I have basically defined a bunch of tools, and the tools are just a name of the tool and the description of what the tool does, and the fields properties. So this is in a format known as JSON schema. And the LLM, when the LLM is called, so here I have like the call, I'm using Anthropic's LLMs, and here you can see that tools are passed to the function in this function called ask, and it's directly passed to the Anthropic API. And it's able to then, it's able to tell me when it's making use of the tool. And then on my end, when I see that it's making use of the tool, I call it on its behalf. So that is the agent definition here. You can see that the description is fairly simple. Like I've not given much. You ideally would give it like more precise instructions on like how it's supposed to behave and all of that. But here I've just said, because I'm templating these agents, and there are multiple of them, there is like a framework agent that I have defined on top. So you can see that I've just told it a bunch of capabilities that it has, and then the description of what it's supposed to do. Similarly, the assistant 2 I have defined and kept, but this is more verbose defined because I'm not templating this that much. Here I've given it like additional steps of how it's supposed to function, like communication, guidelines and like general guidelines, how it's supposed to use the tools that it's given. So this is kind of like how you program an LLM. I use that term like very loosely because you can't actually program it. You just ask it very nicely to do something. So yeah, that's kind of the behind the scenes of this. Moving, I beg your pardon? It's just for testing purposes. So later when this app actually goes into production, I will be giving people the, the choice to select whatever they want. Yeah. And we'll mostly be self-hosting a bunch of LLMs, because we're, the whole open source thing. So yeah, you must be wondering, okay, like that's it. And after I did this, I realized that like the complexity of these apps is not in wiring up different LLMs and like calling tools on its behalf and then giving it the input. It is how you manage the input and output of the LLM itself, like as in the stuff that you actually send, the content. And that is because LLMs offer this like sort of illusions of certainty, which is what I like to think of it as. And that is because they work in like a probabilistic regime. It's not like your actual code. It is not deterministic. And so nothing that involves an LLM works all the time. So one example is because it has comprehension limits. So earlier I showed you all that I was using Anthropic's LLMs. For testing, I was using the LLM known as Haiku, which is a smaller version of Anthropic's LLM. It's like a GPT-4o mini or something. And it kind of got confused because of the context that I gave it. And this is the assistant responding saying that I'm going to use the gameplan.list discussions tool. And there wasn't a tool like this. And I was using the exact APIs that Anthropic gave me, but still I didn't get any guarantee that that is going to work with, that is always going to work. So in this case, it didn't actually work. And the funny thing is it generated this string of gameplan.list discussion, but that string, like with the dot in the center, that is an invalid tool name. So if you send it back to Anthropic, they will throw an error. So there was no such, there's no such tool, and there were no such arguments. So the next one is because there aren't any hard rules inside an LLM, like how your code has a compiler and a parser, lexer, all of those things. An LLM doesn't have any of that. So I asked a local LLM QWQ to format some JSON that I gave it. It said, okay, like here's your formatted JSON. I took that JSON and passed it to JSON diff to compare it with the input against the output. And you can see that it found 37 differences. Basically, it was like a really terrible formatter. Obviously, you wouldn't use it for something like this, just to illustrate that there are no hard rules inside an LLM. Then it doesn't have precise logic, so you wouldn't ask it to do deterministic tasks again, like calculating numbers. So here I asked it to multiply two numbers, and the number kind of looks correct. It's in the ballpark of correct, but it is not correct. It's false. And you wouldn't ask an LLM to handle accounting business logic for you, for instance. You can ask it to do that, and it'll look like as if it's doing that, but you'll have all kinds of errors in your ledgers and your reports. And then finally, if you all have been paying attention, this was in the starting days of ChatGPT, this was like a very common question that people used to ask it, like how many R's are there in strawberry, and used to always get this wrong. So does anyone want to take a guess at why this is always incorrect? I mean, nowadays they have patched for it, but any guesses? Yeah. So here, the LLM doesn't have like sub-token level resolution. And you can see strawberry is broken down into 3 tokens. And the final token, berry, has 2 R's in it. So it can't look inside that. So it has to kind of infer how many R's are there in strawberry from the training data that is there. Like from other words, like if say there's a sentence saying that like, okay, there are 3 R's in strawberry, then it'll probably learn from that. But it can't actually look at the word and then calculate on the basis of that. So a few final takeaways from this are that LLMs have like very unique failure patterns. And this is because like we expect it looks like it's working, but it often doesn't work. I mean, it might work many times, like with the Haiku example that I gave you, wherein it was calling a tool properly. It looked like it was calling a tool properly, but it wasn't. And you have to kind of remember what they're good at, and which is handling your sort of unstructured input, which is a soft rule. So if you ask it some question, it'll be able to infer like what you're talking about, and then convert that into like some like a tool call, and then your code should then like go and handle it. And then finally, you should always verify what the output of an LLM is. Otherwise, you end up with terrible software, and I don't know, like, yeah, you should always verify it. So yeah, that's it for my talk.